The electric guitar dates back to the 1920s. The original idea was to amplify the sound of the acoustic guitar. The first commercially successful model came out in 1932. By the 1950s, though, the instrument underwent a radical change, its body evolving from the traditional hollow shape to a thin, solid block of wood. Guitar bodies are usually made of mahogany, poplar, or certain maple species, lightweight woods that are flexible enough to produce the right balance of treble, mid-range, and bass vibrations. Workers first saw a plank of wood into specific widths. They plane the pieces to a specific thickness, usually in the range of 2 to 4 inches. Then they mark them with the same number so they'll end up in the same guitar. Mixing pieces from different planks would combine different wood densities and make the body vibrate unevenly. Damp wood tends to warp, so the pieces have to go into a heated room until their moisture content drops to less than 6%. This takes about 2 months. Once the wood dries out, workers glue and clamp the pieces together, setting them in a vise for 3 hours until the glue dries. The water-based glue re-wets part of the wood, so the block has to go back into the drying room for another 2 months. When it comes out, it goes onto a holding device. Then a computer-guided cutting machine uses 8 different heads, one after another, to gradually carve the body shape. This is a semi-acoustic model, so the body has some hollowed-out areas. After fine sanding to smooth the surface, they trim the contour at a 45-degree angle using a small stainless steel blade. Then they sand again. By this point, they've also inserted round metal fixtures to hold the bolts that'll attach the body and neck. To construct the neck, they slice a piece of mahogany or hard rock maple in two using a diamond-edged saw for a perfect cut. Then they glue a 0.05-inch thick sheet of maple veneer onto one piece. This will be the front surface of the neck. Now they flip the piece over and glue it to the other one. Flipping inverts the wood grain. This strengthens the neck, enabling it to withstand the tension of the guitar strings. The maple veneer hides and reinforces the joint. They clamp the components in a vise for 3 hours until the glue sets. A computer-guided cutting machine contours the neck shape and cuts a groove down the middle for a steel bar called the truss rod. When the neck bows from tension created by heavy gauge strings, you straighten it by adjusting the protruding end of the truss rod. Next, the fingerboard, the surface against which you press the strings to produce different notes and chords. It's made of maple, ebony, or rosewood. After gluing the fingerboard over the truss rod, they place the neck into a vacuum press. The press sucks out all the air, compressing the components into one solid unit. Once the glue dries, the neck goes onto a computer-guided carving machine. Its 12 different cutting heads finalize the shape. Next, a 22-blade saw simultaneously cuts very precise slots for 22 fret wires, the metal lines on the fingerboard. A worker rounds off and smooths the back of the neck against a belt sander. Then installs the fret wires. The wires are made of nickel and lead. They have teeth on the bottom that grab the wood. That's why it's essential that the slots be a very precise width and depth. Finally, they run the sides of the neck against a sanding belt. This trims off the excess fret wire and rounds off the edges of the fingerboard. Back to the body now. A worker puts it in a silkscreen printer to apply the company name. The ink dries in just seconds under ultraviolet light. After applying a sealant to block the wood's pores, they spray on up to 22 coats of wood stain and lacquer. This protects the wood and gives it a semi or high gloss finish.